Okay, advanced pre-calculus. It is time to do the sine and cosine graphs. All right, this is big stuff right here. The sine and cosine graphs. All right, so we got a little unit circle right here. 1, 0, 0, 1, -1, 0, 0, -1. Remember, as long as you're on the unit circle and you have a t angle, then the coordinate of x is the cosine of t and the coordinate of y is sine of t. Okay, so we are going to kind of take this, we're going to take this unit circle and put it on this coordinate plane, kind of like, it's almost like we unravel it and level it out here. And so we're going to go all the way over to, we're going to take all of these special rights and go all the way over to 2 pi. So let's start here with label a unit circle and refer to it to completely. I'm not going to label all of this. I think we've got a pretty good handle on our unit circle value. So let's just start with 0 for cosine. Do cosine first, is 1. All right, so cosine then is going to start high, if you will. So this is, a high, and sine starts at 0, 0. So when I say cosine starts high, it's going to start at this 1. All right, and then at pi, or let's go at pi over 2. We're just going to go right here. It's at 0, and then at pi it's at -1. Okay, and then at 3 pi over 2 it's at 0, and at 2 pi completes the cycle. So let's get all of these on there. So we'll just do pi over 6. I want to add pi over 4. I don't know how if this is going to fit, but I want to add pi over 4. Pi over 3. Pi over 2. Okay. And then we've got 2 pi over 3. And then 3 pi over 4. 5 pi over 6, and then pi. Okay, and then next is 7 pi over 6, 5 pi over 4, I'm just right here, 4 pi over 3, 3 pi over 2, back at 0, 5 pi over 3, 7 pi over 4, and 11 pi over 6, and we'll end at 2 pi. All right, so we're going to connect the dots here. And so this is going to be root 3 over 2. This is going to be root 2 over 2. Okay, so we've talked about this value before. Root 3 over 2 is at 0.866. Root 2 over 2, about 0.707, and then of course 1/2 is 0.5. Okay, so so that skips this here, but so we're going to go to, this is 1/2. All right, and then our over 3's will all be 1/2, but now we're in quad 2, so we're negative. Our over 6's will be the root 3 over 2, quad 2 negative, and quad 4 back to positive. Root 3 over 2. Okay, so let's plot these. All right, so at pi over 6, I'm about here, and then here, and then at the 60-degree angle right at 1/2, down to 0, and then 1/2 again here, and then down and down, and then up and up, 1/2, up and up, and 1/2. Oh no, sorry, 1/2 here. Let me get that a little higher. There we go, 1/2, and up and up. Okay, so the curve is just a nice smooth this curve like this. Okay. All of those unit circle values sort of mapped out. This is your, right here is right your 1/2 mark. So here, and here, that's -1/2. Okay, right here, and here. Okay, so, you know, it's sort of like this. Okay, so that's cosine. Use the graph to answer the following. Cosine of 90, cosine of pi over 2, 0. Right there. Cosine of 3 pi over 2 is just, you know, also 0. Cosine of negative pi is just, we went the other way, or you can think of unit circle. Negative pi is -1. All right. Cosine function, so the domain, and this is just one unit circle cycle, but it's going to go on like so. Well, this won't go up. It maxes out at 1. It's going to go continue that. It's going to continue these values as you know, infinitely. So you can even look on here and see that. Cosine of x, I want to be in radians. And I'm going to do a zoom 7. So a zoom 7 is trig, and it's taking you from 2 pi to -2 pi. So this is exactly what we just graphed in our notes right there. And the window is a zoom 7, so you can see it's going from -2 pi to +2 pi. All right. Okay. So let's answer some questions. Your domain, all reals. Range, the lowest it goes is -1, the highest it goes is 1. So the abs max is 1, okay? The max value is always your y value. Y values right here. And minimum is -1. It's going to be symmetric with respect to the origin. No, sorry, that's sine. I'm used to doing sine first. Symmetric with respect to the y-axis. It's an even function. Y-axis. Okay, so if you know, right here, if you do the cosine of pi over 4, you get root 2 over 2. If you do the cosine of negative pi over 4, which dips you into quadrant 4, you get root 2 over 2, where sine, cosine is positive, so even function. Graph repeats the same curve at interval lengths of 2 pi, so it has a period of 2 pi. Okay? Describe in words the relationship between t and cosine of t in quadrant 1. As t changes from 0 to pi over 2, cosine changes from 1, right, to 0. This is usually like a 1-point test question, something like this. All right? So you can see that here, cosine goes in quadrant 1, which is right here, cosine goes from -1 to 0. And then on the unit circle, you can see it, -1 to 0. All right. Find the values that satisfy each equation on the interval and all exact values. Okay, so basically here, where is the cosine equal to 0? Well, that's pi over 2 and 3 pi over 2. Okay? So that's t equal. Now to list all of them, then I would take pi over 2. So we're going to take this pi over 2 and cycle it. All right, so we hit 0 at pi over 2 and then at 3 pi over 2. So this is a cycle here. I mean, you know, cosine, we could do plus 2 pi, you know, n times, and then 3 pi over 2 plus 2 pi n. We could do that. But to be more efficient, since these differ by pi, we could just cycle the first one by pi instead. And notice if I cycle that by 1 pi, then that takes care of the 3 pi over 2. So this is the most efficient way to answer this question for part B. This is part A, and this is part B. Okay, so where does the cosine of t equal 1? So this happens at, in terms of 0 and 2 pi, at 0 and 2 pi. And then it only happens over on the right? That's only going to happen right here. That's only going to happen right here. So the 0 happens here and here, which is the difference of pi, but this only happens on the positive axis. So this one has to cycle by, you could do 0 plus 2 pi n, which is just 2 pi n. And that's for all exact values. That means, because, this graph goes forever. You can continue to rotate, or the graph continues to go on forever. So if you put 0 in here, that would take care of that. If you put 1 in there, you would get that. If you put 2 in there, you get 4 pi, so on and so forth. Okay, so this is going to be, where is this going to happen? This is going to be your 60 degree, your over 3, and then your 5 pi over 3 in one cycle. And then we have to just cycle those. We have to answer with both of these. We have to cycle both of those by 2 pi n, because that's not a difference of pi, so I have to answer that part with both of those. And then the last one, this is your 45 degree in quad 2 and quad 3 and sorry, why did I write 3 there? 4. Okay. There we go. All right, so that is how we would answer those type questions. All right, let's go on. I think we're heading on to the sine graph. And then maybe I'll stop the video and start transformations later. So this, we're going to go through a little bit more quickly, kind of now that we have the feel. See if I can't get this in under 20 minutes, the feel of what's going on. Once again, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1, t, as long as you're on the unit circle, cosine. It's your x value, sine is your y value. Okay. All right, so sine then is 0 right here. 1, 0, negative 1, 0. Okay, so let's put all of these on there. 0, pi over 6. Again, I'm going to add the pi over 4s. Just grabbing these values as we move along. Okay. Oh man, why did I put 0 in the wrong place? Jeez. Okay, sorry. There we go. This is what happens when I try to hurry. Okay, and so I'm right here, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and last one, 11 pi over 6 to 2 pi. Okay, so sine goes here, and then it goes up to 1, and then back, and then down at negative 1, and then back. Okay, so we've got this 1/2 mark and this negative 1/2 mark. Okay, so that happens at your over 6s. Okay, and then this just kind of creeps up. That's that 0.7 and that 0.8-ish. And same. jumped the gun on that one. You can just follow the wave here and see. Oh my goodness. This one's down. Okay. I should have just gone in order here. And then there, and then there. All right, so it goes like this. Okay, and so that's the sine graph. And again, it's going to go and go continuously. So let's look at that. Sine of x on, zoom 7. So you can see it looks like that. So sine starts low. Sine starts low. Cosine starts at 1. Sine starts, I guess I wouldn't say low, but at 0. Okay, so that's a really nice little curve there. So this is your Q1, it's above, Q2 below, Q3, and Q4. So positive and the negatives. All right. Okay, so let's put these values in. So this was 1/2. This was 1/2. This was negative 1/2. This was negative 1/2. This was root 3 over 2. This is root 3 over 2. This is negative root 3 over 2 and negative root 3 over 2. Okay. Moving on. To answer these questions. So sine of 180 is sine of pi, that's 0. Sine of negative pi over 6 is going to be in quad 4, and that's negative 1/2. And then sine of 3 pi over 2 is negative 1. These are just values you should know from our unit circle stuff. Okay. Domain here is negative infinity to infinity, negative 1 to 1. This is easy. Those are the same. Now we're symmetric with respect to the origin. It's an odd function. If you do the sine of pi over 4, you get root 2 over 2. But if you do the sine of negative pi over 4, you're dropped into quad 4, which is negative root 2 over 2. And we repeat every 2 pi, so it has a period of 2 pi, just like cosine. So what happens is we go from 0 to pi over 2. That's Q1. Sine changes from 0 to 1. Okay? So these are your x values, right? That's that coordinate 1, 0, and that's the coordinate 1, 0. So sine changes, 0, 1. Sine changes from 0 to 1 in Q1, which is here. Yeah, so again, this is usually like a 1-point test question. Okay, so where is sine decreasing? So a sine is decreasing, then if you look at just where you're going downhill, you start to go downhill at pi over 2 all the way to 3 pi over 2. Okay, you can answer it with parentheses or brackets. We'll talk about that at length next year in calculus. So just either one is fine for now in pre-calculus. All right, so we're going to do all exact. We're going to do on the interval and all exact. So where's sine 0? It is 0 at 0 and pi. And those differ by a pi, so to write this effectively, I can just say pi n. Every pi n, this will happen. Where is it negative 1? This is just at 3 pi over 2. And so you just got to cycle that by the period. All right. Negative 1/2, so that's your 30-degree angle. So that's your over 6. And that is going to be for sine in quad 3 and quad 4. And you're going to have to cycle both of those to give all the values. And last but not least, I think that is positive, yeah. So this is our pi over 4 and 3 pi over 4. And then this is, both of these have to be cycled by the full period. Okay, I hope you can read that. I'm kind of close in here. Okay. So, sorry I have some minor errors here and there, but I fixed them all, so just doing these videos on the fly, so that's what we get. All right, guys, I'll make another one for the transformations, which come for the next 3 pages of 6.4. Okay, thank you. See you later.